All right, we're back. We're still on page 80 of math analysis. We are solving trig equations. I said we are going to start this video by checking the answers that we got to part A here last time. So if you recall, we did a u substitution. We let u equal this. And like over time, you're going to stop writing down the actual u part, but I think initially it's a really good idea. So I wrote down let u be this. And my whole problem became a lot simpler. Now I just need sine of u to equal radical 3 over 2, which I can do in my head. That's definitely pi over 3 and 2 pi over 3. So like we knew the answers. So then we wrote those down, including generalizing them. And then, I just keep saying and then we replace u with this again and solved. So I'm going to check and see if these are in fact the answers. I think I'm just going to solve, just use solve and see what the calculator says. So I'm going to do solve sine of 3x minus pi over 6. You should use the pi key, by the way. Like I always type pi, but I also type sqrt, squirt, for square root. When I press enter, it's going to convert it. The pi key's over here. It's its own key. So in case you've never used it, make sure you're aware of that. You should not be typing pi on a handheld. Now these don't look like I would like them to look. So I'm going to expand. So expand is menu 3,3. So if you're not sure. And then I need to add 2 pi over 3. So where does 2 pi over 3 come from? It's because it's in here. Just ignore the n7. Like basically you're letting n7 be 1. And you get 2 pi over 3. So I'm just adding 2 pi over 3. I get 5 pi over 18, which is what I got. And then on this one, if you look at it, you can see that I think we definitely got it right. But expand that, pi over 6 plus 2 pi over 3n. Which is what we got. All right, so let's go back and try to solve the last problem on here. Hopefully we can get back. Had that problem. I always get like a little anxious when it has a problem. So it had a problem like 1 or 2 videos ago. It's like, oh my God, is it never gonna work again? But it seems to be working. So solve a simpler problem. That's basically what u substitution is all about. So let's let u equal 2x plus pi over 4. Which means I'm really just trying to solve cotan of u is negative radical 3. So I'm going to try to do this in the most efficient way possible. Sort of. First of all, I don't really know what this is, so I'm going to switch it to tangent and take the reciprocal. So I get negative 1 over radical 3, but just rationalize that and you'll get negative radical 3 over 3. Now I just need to think, where does that happen? So this can be helpful. So A, S, T, C, so here or here. Now we're in that scenario where they're going to have the same reference angle, which means they just differ. If I can figure out one of them, they're just going to differ by pi. So I'm going to write only one thing here. So what type of angle has a tangent of negative root, what types of angles have tangents that are root 3 over 3? It's the pi over 6's. So I know that u prime is going to be pi over 6. Now I need it in, let's say, the second quadrant. So that would be 5 pi over 6. And then I'm just going to add pi, because if I start here and I add pi, I end up here. If I'm here and I add pi, I end up here. So I only need to add pi times n, where n is going to be an element of the integers. And then we do our reversal, right? Because the question wasn't about u, it was about x. So if we make our substitution, and so I usually try to do a common denominator on this step. So I'm going to say that 2x plus, I'll use 12, 3 pi over 12 is equal to 10 pi over 12 plus pi n. And then I'm going to say 2x is 7 pi over 12, still plus pi n. And then x is 7 pi over 24 plus, and this is why you generalize as soon as possible. Generalize as soon as you know, basically when you're solving the u equation, right? When you're going to figure out what u is, generalize there, because anything that you have to multiply or divide by, it's got to go with your generalization also. So here it'll be pi over 2 times n, where n is an element of the integers. So I will, I'm going to check this. I'm going to do it two ways. I'll use solve, but first I'm going to try to just evaluate the function and see if my values work. So I need to do the cotangent of 2x plus pi over 4. And I want to do that such that x is, so I think 7 pi over 24 should work and give me negative root 3. And it does. It's such a good feeling. Like I know what I'm doing, but even then, it's like, feels good. I'm going to add pi over 2, so I basically let n equal 1, and it still worked. Good. All right, so I think I solved it. So I'm confident in my answer at this point. Let's also use solve and just like, double, quintuple confirm. We want to solve for x. We got to expand that. So expand, here, I'll do it from the menu, is menu 3, 3, and then blah. And then it does the negative thing. So I'm going to let n8 equal 1. So I'm basically just adding pi over 2. I get 7 pi over 24 plus pi over 2 times n, which is what we wrote on the paper. So on the paper, whatever that means. So we're good. So let me go back. So this idea, u-substitution, man, huge, huge idea. You're going to be using it all over the place soon. Soon meaning like in the next couple of years. But during the next couple of years, not like in a couple of years. You're going to start this year, and it's just going to stay with you through basically all of calculus. So you'll see it all the time. The other thing, so I got it down there. You can look and see. And then I don't mention this usually. I don't think I've mentioned it in any of the videos. No, actually for note 7, I mentioned it. There are like other videos that go along with these notes that I made over the years. This, because of like who knows what's going on in the world, is the reason I'm currently like recording all the actual notes. But there are like helpful videos, there's more problems, there are examples, there are other approaches, like all kinds of videos that match up with these. And on my website where you got these notes, underneath the notes, it should connect you to a playlist and you can watch those too. So I definitely recommend it. They're pretty neat. Usually I made those in response to someone not understanding something I did when I was explaining the notes. So if you're watching these and thinking, I don't get that, there's a good chance there's another video trying to explain it better. So maybe take a look at those too. But anyway, I'll be back in the next video and we're gonna keep going. So see you there.